Understand the dual factors governing molecular polarity. A molecule's overall polarity, net dipole moment, depends on two fundamental concepts. Bond polarity, the electronegativity difference, delta Chi, between covalently bonded atoms, which determines the magnitude of charge separation, delta to the power plus and delta to the power negative. Molecular geometry shape the spatial arrangement of those bonds, predicted by Vesper theory, which determines whether the individual bond dipoles reinforce one another or cancel out symmetrically. Analyze and eliminate symmetrical molecules. Zero net dipole carbon disulfide, CS2 possesses linear geometry, 180 degrees bond angle. Because it is completely symmetrical, the two polar C equals S bond dipoles pull in exactly opposite directions and completely cancel each other out. Thus, CS2 has a net dipole moment of 0 and is nonpolar. Boron trifluoride, BF3 possesses a trigonal planar geometry, 120 degrees bond angles. Despite having highly polar B, F bonds, the three bond dipoles are arranged symmetrically in three directions and completely cancel each other out, making the molecule nonpolar. Analyze the remaining asymmetric molecules. Diatomic species. This leaves the two diatomic interhalogen compounds, ClF and BrF. Diatomic molecules are inherently linear and asymmetrical, meaning their individual bond dipoles cannot be canceled by other bonds. Their molecular polarity is determined entirely by the polarity of their single covalent bond. Compare electronegativity differences using periodic trends. Electronegativity measures an atom's ability to attract shared electrons in a covalent bond. Electronegativity increases going up and to the right on the periodic table. Fluorine, F, is the most electronegative element. Looking at group 17, the halogens, electronegativity decreases as you move down the group. F greater than Cl greater than Br. Therefore, bromine, Br, is less electronegative than chlorine, Cl. Determine the molecule with the greatest dipole moment. Because Br is less electronegative than Cl, the electronegativity difference between fluorine and bromine is greater than the difference between fluorine and chlorine. Delta Chi Br, F greater than delta Chi Cl. F. This larger electronegativity difference in BrF results in a more unequal sharing of electrons, producing larger partial charges. Delta to the power plus on Br and delta to the power negative on F, and a greater overall molecular dipole moment. Therefore, BrF is the most polar molecule, matching option B. The correct answer is option B, BrF.